Hello, everyone, and welcome back. Today, I'm going to be going over graphing and solving linear inequalities. Okay, so first let's talk about how do we solve them. Well, to solve them, we do actually almost the exact same steps we would do when solving equations. The only difference between how we would solve a linear equation versus a linear inequality is that whenever we multiply or divide a negative through the inequality sign, the sign flips, right? So if we multiply or divide a negative sign through the inequality, that means a greater than sign becomes a less than, or a less than becomes a greater than, or greater than or equal becomes less than or equal, and less than or equal becomes greater than or equal. So that's the only difference. Okay, so let's start with this first one here. 2x plus 6 is greater than or equal to 8. Okay, so first we want to subtract 6 from both sides, so I'm going to do that. And if we do that, we're going to get 2x is greater than or equal to 2. Then I'm going to divide both by 2, and we're going to get x is greater than or equal to 1. So in this case, the sign didn't change. The sign in the beginning was greater than or equal to. And in the end, it was still greater than or equal to because we didn't multiply or divide any negative signs through. We did subtract 6, but subtracting 6 is not the same as multiplying by -6 or dividing by -6. And so that's the difference there. We can still subtract and it doesn't do anything. Okay, so x is greater than or equal to 1. First thing I'm going to do, because it's equal, could be equal to 1, is I'm going to put a filled in dot right on 1. And it says greater than or equal to. So I need to put every number that's greater is going to be included here. So I'm going to draw a line like that, and also the arrow as well, because this is going to continue on forever. Any number that is 1 or greater than 1 is included here. Now let's say it was x is strictly greater than 1, then we would have an open hole rather than a filled in hole. And we'll see that in the next example. Okay, so in this next example, it's 5x minus 4 is greater than 11. So first thing I'm going to do is I'm going to add 4 to both sides, and we're going to have 5x is greater than 15. Then I'm going to divide both sides by 5 to get x is greater than 3. So 3 is our boundary. However, in this case, because it's strictly greater than 3, not greater than or equal to 3, that means that we are going to do an open hole on 3 like that. And then it needs to be greater than 3. So I'm going to fill in everything to the right of 3, because everything to the right of 3 is greater than it. And everything to the left of 3 will remain unshaded, since that wouldn't be included here. All right, and let's do one last one for today. First thing I'll do to solve this question is subtract 3 from both sides. And that will give me negative 2x is greater than 14. Then I'm going to divide both by negative 2. And when I do that, what's going to happen is the sign is going to flip. So we're going to have x is less than negative 7 rather than greater than. It started as greater than, but remember when we multiply or divide a negative number through our inequality sign, we flip the sign. Now, since this is x is strictly less than 7, less than negative 7, not less than or equal, I'm going to do an open hole right here, like that. And then everything that's to the left of 7, everything that's less than, is going to get filled in. And as you can see, if we look at these numbers, negative 10, negative 9, negative 8, all of these numbers seem to be less than a negative 7, and so that's a good sign as well. All right, well, good work today, everyone, and I will see you for the next one.